Hi there, welcome to Mr. Morgan's Math Help for Algebra 1 or Integrated Math 1. So it could be also IM1 is your course as well. So it might not just be Algebra 1, that's all right. We're in Unit 1 today on one variable statistics, which the lesson is Lesson 9 called Technological Graphing. I'll tell you up front right now that some of the activities today for today's lesson are not ones I really can do in my iPad very well. We'll do as best we can. The homework part will be just fine. You don't need to use a lot of technology for that, but we'll make it through it. All right, so let's use technology to represent data. And the goal today is that I can create graphic representations of data and calculate statistics using technology. Again, this is a part I really can't do. You should be able to in a spreadsheet. All right, if you had a spreadsheet with a bunch of numbers in it, all right, you have your numbers and data value. That spreadsheet's going to have tools up above that's going to allow it to convert things into things like a bar graph like so, a histogram. You can also make a dot plot automatically from the values. It'll also make for you the box plot as well. So the spreadsheet is pretty cool because there'll be features up above in your tools that will automatically create different graphs and charts for you. On the iPad, I just don't have those on here to do it. And so I'll just talk you through it and you'll be okay. But it's something to practice with, play with. And here we go. So first of all, on a spreadsheet window, enter the data set so that each value has its own cell in column A. So we can see here's column A, and we're going to type in all these data values into a spreadsheet, which I have done right here for us. Okay, so I have that there, no problem. All right, how many values are on the spreadsheet? Well, we can look at it. Again, it's here. The easiest way to see how many values are is we look at the last number in A1, and we see that it goes down to, or the row numbers go down to number 20, right? So the row numbers go from 1 all the way down to 20. So in terms of how many values are in the spreadsheet, we'd say there's 20 of them. If you enter the data in the order that the values are listed, the number 7 is listed in the cell at position A1. Okay, so there's 7 at A1. And the number 5 is in A5. Okay, list all the cells that contain the number 13. So here's a 13 there, and a 13 there, and a 13 there. So we have 13 at A4. We have 13 at A12, and a 13 at A14. It says in cell 1, type the word sum, and in cell 2, type the word mean, and then median. You might wish to click or drag, so all right, cool. And you can see I've done that already. I put it in D. There's my sum, mean, and median. So I type those words in like it wants me to do. And then next to the word sum in cell D1, I'll put it in C1, we're going to type in the sum equals A1 colon to A2. All right, let's take a look at what happens when we do that there. Let's put it in C1. I'm going to say that this equals the sum, parentheses, of A1 colon A20. Notice how it highlights all the values there for me, and sum means to add things up. So now when I press enter, it's automatically going to calculate all those values when you add them all together. Pretty cool. Now to find the mean, I can do the same thing. I can do equals to. Now again, on my computer, I have to type in average. You might type in mean on yours. And I could say from A1 all the way to A20. And again, it's going to give me the average of all those numbers. And there they are. Handy. All right, median. Guess what? It'll also tell me the median. So we type in median, A1 all the way to A20, press enter, and the median value, if you were to organize those in a straight line, line them up, smallest to greatest, is going to be at 8.5. Okay, so those are our values for our sum, our mean, and our median. If we were to change the value in A1, right here, this first one, to 8, how does that change the statistic? Well, let's change it real quick. First of all, I'm going to write down what I had to begin with, just so I kind of keep track. I'll put it here in E. I had 178 I had 8.9, and I had 8.5. Just remember what I had. So I'm going to change this one value, increase it by 1. So my overall, adding 1, my sum should increase by 1. My mean might increase. It is good. I have a higher value. The median, let's just see. All right, 8 goes there, and there it is. I can see that my sum did increase by 1. The mean went up a little bit because I had a little higher value, but the median stayed exactly the same. And that makes sense because the middle value is not going to change necessarily, okay? Because the middle is still the middle, 7 and 8, not that different. It's going to be about the same there. Now, it says change the value in A1 to 8. We got that already. Now it says what value can we put in A1 to change the mean to 10.05 and the median to 9? Okay, so we want to get this to our goal is to get to 10.05 and get that to 9. Well, let's see. Well, if I put in 10, nope, getting closer. My median is at 9, so that's good, but the mean is not there yet. If I put in 20, getting bigger, not quite. Let's put in 30. Hey, look at that. If I change the first number to 30, then the mean becomes 10.05 and the median is at 9. So just continue to add a larger value, does increase the mean, and pulls the data a different direction. That's that skew stuff we've talked about before. Okay, interesting. All right, so here we go with the stuff that I can't really do a lot with my computer. It says we can use technology to create data displays. All right, what's wanting you to do is to take the data that you use in the warm-up and then select the histogram as the graph type and change the settings to show 7 classes. Now you could probably do this on your computer, and what it's going to do is it's going to give you the statistics that you normally see. You're going to see things automatically like the mean and the median, okay? You'll probably also see the maximum and the minimum when you play with that data set there. Number 2, change the settings so that 5 classes of data are shown. So you can decide how you want to group the histogram with 7 classes or 5 classes, and it's going to change what appears there. Okay, so with 7 classes, your bar is going to have a certain length. With 5, it's going to be a different length. Okay, it's going to change your bar width there because of the number of classes. Okay, in 3, it says change the graph type to look at the box plot of data. So box plot. So now we're looking at one of these guys, right? So what's that going to look like? When looking at the box plot, notice there's an X near the box plot. So some kind of X is hanging out there. This represents a data point that is considered an outlier, meaning it's just not quite fitting in with the rest. It's pretty far away, like the spread is pretty far away. Click on the settings button and uncheck the box labeled outliers to remove this point from the box plot. What changes? Well, what changes is probably the X goes away. Sometimes you want the outlier and sometimes you don't. That means you can either include or exclude an outlier, right? So if you think back to your data points, let's go back to the ones we had here. For this data point here, we know the average was 9, but I have a 1, I have a 2, right? Those are all pretty much in the range there as my low ones, a 1, a 2, and then it just jumps up to 4. Then I have 4, 4 if I put them in order like so. Then high numbers, I have a 15 and a 15. But what if I was to keep this one as a 30 like it was before? Well, that 30 doesn't fit with most of those values, right? It would be considered an outlier. Now, an outlier, if you think about our data, is going to pull the data way out there, right? I have my 3s, my 4s, my 5s, my 7s, 8, 9. Then I have this 30, which is going to stretch things. That 30 is going to pull the mean to the right. This skews the data to the right. And sometimes by including that number, it's going to give me a value of center that doesn't really help me in what I'm trying to learn or figure out. So sometimes you might want to include it. Sometimes you might want to exclude it, depending upon what type of information you're looking for. Those little outliers may or may not be very helpful to you. Okay, use the data collected from a previous lesson, which I've included right here for you, to create a dot plot, box plot, or histogram. Again, you could plot these into your computer, do that for you. And so if it was doing a dot plot, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've done this before. We have a 0, 0, 1, 1, 1. We have 1, 2, 3, 4, 5, 6, 7 twos. 1, 2, 3, 4, 5, 6, 7 twos. I have 1, 3, 1, 4, 2 6s, a 7, an 8, a 10, and a 12. So I could have a dot plot like that. I could make a histogram if you wanted to, depending on how you wanted to break that apart. I could have 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, and 10 to 12. And 0 to 2, 0, 1, 2, 3, 4. It's going to have 7, 8, 9, 10, 11, 12. Be really high there. And then, or 0 to 1, really. That's usually what we do. Sorry about that. It'd be 0 to 1, which is going to be 5 there. And then 2 to 3, it's going to be 7, 8, somewhere like there. And then 4 to 5 is a 1er. And then 6 to 7 is 3. So that's going to be somewhere about there. And then 8 to there, it's like 1. And then 10 to whatever was 1. Okay, get the idea. And then, of course, we could do a box plot as well by looking at the data, which we said we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So find the middle at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's my middle spot there. The middle of the middle is going to be 5. 1, 2, 3, 4, 5. So that's my quartile 1. 1, 2, 3, 4, 5. Quartile 3. Draw our box like this. Going to go out to 12. Go down to 0. Okay, so our mean, in this case here, to find out the mean for this value, I'm going to need to add up all those value points right there. So to find the mean, I'm going to add those all together. And when I add the numbers and then divide by 20, what I end up with is a mean of 3.65. If you're on your computer, it's going to tell you the mean automatically. The median, we can see clearly, is here at 2. Okay. And then the interquartile range is Q3 minus Q1. Q3 is 6. And Q1 is between 1 and 2, so it's 1.5. So 6 minus 1.5 is equal to 4.5 for my interquartile range. All right, so those are my values there. But again, using technology, it will give you those data points automatically for them, okay? So that's what we have there. We can see that the data is going to be a little skewed because of this 12. If I was to actually draw that out on a number line, like let's use this number line here, up above, right? My median is here at 2. My interquartile range goes down here to 1. And the other one goes up to 6, which is here. And then I have a minimum, and I have a maximum way over there. So you can see how that maximum at 12 skews the data. It pulls the data to the right, meaning that the mean, 3.65, which is about here, is farther away from the median, okay? And that's because of that outlier pulling the data in that direction. All right, so data displays like histograms or box plots are useful tools for quickly understanding large chunks of information, but often take a long time to construct accurately using pencil and paper. Technology can help make it faster to create these and calculate useful statistics faster than by doing it by hand, especially with very large data sets, okay? It's helpful to use technology for that there. A statistic is a quantity that's calculated from sample data as a measure of distribution. Mean and median are examples of statistics that are measures of center, and mean absolute deviation and interquartile ranges, IQR, are examples of the measures of variability. So those are the things we've been talking about. Mean and mean go with center. Mean absolute deviation and interquartile range go with measures of variability. All right, you still have to interpret what they mean, but those are ways we calculate center and variability when looking at data. Here's your cool down for the day for you to work on and check in with your teacher to make sure you're getting it before you head on out of the class. So we can pause it there if you like and then do that. I'm going to move over to the homework slide and remind you once again, do your homework on your own and then come on back in and check to see if you're getting it. And that way you know what kind of questions to ask in class tomorrow when you see your teacher after you've done the homework. Try to listen to me a little bit, see what's still not making sense. So here we go, homework time. Technology required. All right, the data represents the average customer rating for several items sold online. So here's our data. Use technology to create a histogram. There's your histogram for the data with intervals 0 to 1, 1 to 2, and so on. So if you were to put this on a computer, you could create a histogram that would look something like that. Describe the shape of the distribution. Well, this distribution, we have kind of the larger part here, and then it curves that way, right? So in this case, because we have a bulk of numbers over here, we can see that our little numbers are over here, so it's kind of pulling it that way. We'd probably call this as skewed left, if anything, okay, because it's kind of smaller and then it gets bigger and drops off. So it's skewed to the left, okay, because and it kind of has a center point. Somewhere around here is my center point of 3, and that's because of all these values over here. Even though I have a big chunk of values here, my center is somewhere around 3, even though it probably should be more like, 4, something like that. But these lower values are pulling the data to the left. Which one has the highest frequency? That's going to be here between 4 and 5. Has the highest frequency. It's the highest bar. Has a frequency of 8. All right. Next question. Technology required. Not really. Okay, the data here represents the amount of corn in bushels per acre harvested from different locations. Use technology to create a dot plot and a box plot. There they are. What is the shape of the distribution? Well, let's draw it. We have a curve goes up and then pulls that way, right? 1, 2, 3, 1, 2. Like this is kind of like how it, if you were to just look at this part here, you can say that looks normal. Great, no problem. The problem is I have this extra part over here pulling the data that way, which you can really see with the box plot, right? We can see that while I have my data there and my median there, these values are really stretching it that way. So we would say this is going to be skewed right, with a center going to be somewhere more like, if you look at your box plot, the center of all these values is somewhere more about here. That's our center. But it's not quite what the center value should be because of that skewed data there. If you compare them, again, it helps you see the difference. For this one, we can see what the median is going to be easily enough. Okay, we can calculate that. With both of them, we can see our minimums, we can see our maximums. Those are the same there. And this one, you have your individual values because of the dots, where here there's no individual values. So just different ways of looking at the same data. Depends on what kind of information you want to get out of it to decide which sort of graph or graphical representation makes the most sense for you to use. All right, let's describe this histogram right here. Okay, we can see we're going to go up and curve, and then we pull out to the side. Okay, we're curving that way, so we would say this is, again, skewed. And which way is the pull going? It's going to the right. So we'd say it's skewed right in this case here. Kind of looking at where the middle of all the points are, probably somewhere around, oops, that's the wrong button. Somewhere here around 9 is where center is going to be. So it's a little bit pulled that way. So how many values are represented here? To find values in histogram, I need to kind of see what's on top. This is a 3, this goes to 5, this goes to 7, this goes to 2, 1, 1, 1. Then I have to add those up. So I have 7, 12, 15, 16, 17, 18, 19, 20 are there. And what statistical question could have produced a data set summarized here? Well, if you're looking at values with up to 3, 5, 7, whatever it's going to be there, or for 0 to 3, this is like how many, maybe you're talking about 20 students did push-ups in class today. How many push-ups did the kids did? Well, there are 3 kids that did between 0 and 3, 5 between 3 and 6, 7 between there, and we have like one person that could do 24 to 27, one person 18 to 21, but most people were in this range over here for how many push-ups they could do but you got a couple stronger kids that like doing push-ups, and this guy just went all out, or gal. Whoever did it, fantastic job today on the push-ups. Way to go. All right, so just make up your own little story there. The dot plot represents the distribution of satisfaction ratings for a landscaping company on a scale of 1 to 10. How happy were people with the service? 25 customers were surveyed. On average, what was the satisfaction rating? Okay, so average, there's two ways we could find the average, right? We could find the mean or the median. Now, the average really means the mean, but that's going to take a lot more math, right? To find the mean, we're going to have to add up all these values, add them up, and then divide by 25. Now, when I add all those values up and divide by 25, I'm going to add up 1 here. I have a bunch of 5s. I have 7 5s. That's 35. I have a bunch of 8s. In fact, I have 11 8s, so that's 88. Here I have 4 9s, so that's 36. And here I have 2 10s, it's 20. When I add all that craziness up and divide by 25, I end up with a mean of 7.2. A lot of math there. The median, in this case here, besides this crazy outlier, this outlier might skew the data a little bit, but the median's going to probably be okay because the data's, it's not uniform, but it's not terrible. So let's take a look at the middle point. That's going to be a point at number 12. So we have 1, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the middle is going to be there. So half the values are here, and half the values are here. So the middle value, the median, is going to be at 8, right? Is there a huge difference between those? Not massively, right? So customer service ratings went from 7.2 to 8. The mean is definitely lower than that and then 8, right? And that's because if this is 8 for the median and the mean is right here at 7.2, the reason that's a lower value is because you have this larger chunk pulling things down, plus this one value really pulls the data to the left. So it's going to make the mean less. Okay, that's about it for the day. Hope that helps you out and you have a great day, and we'll see you next time. Bye.